Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. You are going to create this water tower calculation. You must be thinking, water tower calculation, what is that all about? Well, I remember years ago when I was taking Fortran programming, my professor gave us this problem, and so I am passing this to you. Here's the idea. Let's pretend that you live in a rural area and you have three houses. So let's say, for example, you have house 1 over here, house 2 over here, house 3 over here, and you've decided to share water between the three houses to be able to feed the crops, or to provide water for the crops, say for example. All right, well then the question then is, where would be the best position for the water tower? Obviously, the water tower should be somewhere in the middle of this triangle that's formed by connecting house 1 to house 2, 2 to 3, 3 back to 1. So if you can imagine a triangle, right in the middle of that triangle is where you're going to want to place your tower. Obviously, if you place the tower further away, that would not be good because pipe is very expensive, right? The pipe to get the water from the water tower to the houses, say for example. So the question then is, where should the water tower go? Well, the first thing you're going to allow the user to do is to enter in a Cartesian coordinate. So for example, we're going to use this drop-down combo box here approach, and they can select any one of the numbers, say for example from 1 through 15, and for both the x and the y-axis for house 1, house 2, house 3, and then after the user clicks the Show Houses button, then these three houses will appear. When the user clicks the Show Tower button, then the water tower, which is WT, that label will appear. And then of course if the user clicks Clear, then none of the options are going to be available or are going to be displayed on the screen. And then of course if the user clicks Exit, that'll stop the program. So the idea again is, where should that water tower be placed? I've already created a program, or I've already created the program. Let me just run it just to kind of give you a sample of what this is going to look like. So at first when we run the program, notice that nothing is displayed. So when I click this combo box, the first entry is going to be blank, and then we have 0, 1, all the way up to 15. So let's say that the first house is located on 1515, say for example. And then the next house is going to be on 115, say for example. And then the last house is on 15.1. When I click Show Houses, notice what happens, right? So the first house is on 1515. So here's the x-axis, here's the y-axis, and notice that house 1 appears there, 1515. And then house number 2 is on 115, so x-axis 1, y-axis 15, so there it is. And then house number 3 is on 15.1, which is right here. Now, based on these three houses, where should the tower go? So we'll click the Show Tower button, and it says here the tower should be on 1212. That would be the least distance. And then of course if I click Clear, everything is cleared here, everything is cleared here, and then if I click the Exit button, you see what happens as well. Alright, so here's a couple of things to notice about this program. Let me go ahead and start it again just to demonstrate this. Well, of course, I'm going to introduce the combo box, right? So I can go ahead and use a combo box to enter any of these values that I want. And let's say, let's put this one over here at 13, say for example. Click Show Houses. Okay, well first of all, only when the user clicks Show Houses, then we can go ahead and click Show Tower. Then when I click Show Tower, the tower will appear. So actually I think the placement of this thing makes it difficult to show the tower here. So let's move this to 0, 15, say for example. Show Houses. Okay, there we go. And then I'll click Show Tower. All right, there we go. Now, here's the problem, or not the problem, here's the issue that you have to consider. What I want you to do is to place the houses on one of the intersections of the Cartesian coordinates. So in other words, it is not possible for a house to be located at 2.5 and 2.7, say for example. It has to be located on an intersection somewhere on this Cartesian coordinate. That's the first thing to consider. Second, you want to also consider the boundary of the houses, or the water tower possible placement. The idea is this. If you were to take house number 1 and then house number 3 and then house number 2, you could see the boundary that is formed by these three houses. Well, obviously the water tower is going to go somewhere inside of that boundary. So the idea is this. Let's put the water tower here, or here rather, and find out, is this the best location? Consider the distance between the water tower and all three houses, and then put the water tower here, and then put the water tower here, and then here, and here, and here. So the idea is that you are moving the water tower to different locations. So let me just give you an example of that. So let's say, for example, that the water tower was here. Okay, get the distance of that water tower, current position, and all the houses. Now move the water tower to here, and get that water tower distance between all three houses, add them up, and see which one is less. If the current distance is less, then this will be the best position so far. Let's move the tower over here and ask the question again. What is the distance between here and here? Water tower in house 2, water tower in house 3. If that distance is the least one so far, then let's remember this position. And the idea is you're going to kind of scan the maze, or not scan the maze, scan the grid by moving the water tower to each of these different intersections. Finally, when it comes up to here, then you're going to move it to row number 1. And then you're going to scan through the entire 1 grid, and then you're going to move it to number 2. Scan the grid. Move 3. Scan the grid, so forth and so on. And basically, every time you're coming up to a new location or moving the water tower to a new location, you're basically adding up the distances between the water tower and each of the houses. Right? So 1, 2, 3. You're adding them up and finding out, is that one the least so far? Because that's what you're striving for, to find out the least distance. All right, so this is a perfect example for 2 for loops or 2 while loops. The idea is one loop is nested inside of another loop to be able to scan the entire row and column for the Cartesian coordinate. Okay, well, the first thing to do is let's go ahead and talk about designing this thing. And what I want to show you is this. First of all, I just got 3 labels, as you can see here. Let me go ahead and give you the names for those. Put this over here. Sorry about that. And here we go. All right, so this is going to be LBLH1, LBLH2, LBLH3, and then this one is going to be called LBLWH, WT rather, for the water tower. All right, so these are just 3 labels that I am labeling, or creating rather, to represent the houses and also the water tower. Notice that the houses are blue, so I just changed the 4 color, and then the water tower is red. I changed that 4 color to red. So that's pretty easy. This is a group box. So all I did was I just simply went over here and scrolled down until I got to the group box area. So the group box is over here in containers. Here it is. I dragged and dropped a group box over. And then after I dragged the group box onto the form, then these are just 2 labels right here. Now this right here is a combo box. So the combo box, let me go back up here, that's this guy right here. The idea behind a combo box, first of all, I just dragged this right into the group box. And the idea behind a combo box is if you were to click on it, it gives you a listing of various options. So you get a chance to restrain the user's input. And I'll run the program again just to show you this really quickly, but I think you saw it on the first run. The idea is when you click the combo box, it gives you a list of values, whatever values that you determine. So in this case, the first value is blank, second value is 0. Next one is 1, so forth and so on. So I have all these values up to 15. When the user selects that, then that becomes the currently active value. And in fact, I think as you can see here, I'm just showing you all the different values here. All right, let me go ahead and close. All right, so now that I have the group boxes, I can have the combo boxes, and this one I called CMBH1X. This one is CMBH1Y. CMB is the Hungarian notation for a combo box, so that's pretty easy. And then H1Y and H1X, that's just to represent, in this case, either the x-axis coordinate or the y-axis coordinate for the house. So this would be the combo box for house number 1, y coordinate. That's this combo box. This one would be combo box for house 1, x coordinate. And in a similar fashion, we're going to do the same thing for this drop-down box, combo box H2X. This one will be combo box H2Y. This one's going to be combo box H3X. This one is going to be combo box H3Y. Okay, so again, all you're doing is just creating the group box, then drag and drop a couple of labels in here, then drag and drop a couple of combo boxes. Okay, do that 3 times. For this button, that's going to be BTN show houses. This is going to be BTN show tower, BTN clear, and then we have BTN exit. Alright, so that's the easy part. Let's now talk about the more difficult part, which is creating these lines. This isn't going to be such an easy thing at first, but it's not a difficult thing. It's perhaps maybe moderate. So let me go ahead and just select one of these lines here and show you what this really is. It's just a label, right? So all that I've done is I'll just take a label. So you know how to create a line already from previous lectures. We'll just take one of these labels, drag and drop it to the form. So let's say that I drag and drop this label over here. Okay. Well, the first thing that I'm going to do with that label is I'm going to change the auto size to false. So by changing the auto size to false, I can now change its size. And then what I'm going to do is I'm going to change the back color of this thing to black. Okay, so now that I've changed that, I can go ahead and stretch this as much as I want, and I can also reduce this as much as I want. Well, the only problem is that when I try to reduce its height in this case, it doesn't allow me to go to 1 in terms of its size. So what I need to do is I need to go ahead and activate or expand the size category, and it's specifically in the height. I'm just going to type the number 1, press enter. Now you can see what happens. Now in this case I could take my mouse and drag and drop this to the position that I want, but in this case I favor using the arrows on the keyboard. So I'll use these arrows to move them into whatever position that I want, and then I can go from there. Alright, let me go ahead and delete this particular label, and I'm going to explain to you the difficulty. See, what has to happen is this line and this line and then this line and then this line, so forth and so on, they all have to be the exact same distance. Okay, so in this case, notice what I have here. It looks like I have each one of these lines are 300 in width, and then therefore each one of these lines over here are 300 in height. Okay, so that's the first thing. If you want to match the size of mine, I made mine 300, okay, in terms of the width and also in terms of the height. How about the spacing? Well, check this out. Okay, so let me select this first line here. Let's see if I can select it right there. Okay, let's go to the location. Notice that the location for this thing, in terms of the x-axis, it's 43. In terms of the y-axis, it's 20. All right, let me go ahead and select this one, and then you'll see in terms of the x-axis, it's 63 and 21. So we went from 43, 63. This one should be 83. The next one should be 103, so forth and so on. So can you see that I have them 20 points across? So there's 20 points of space from this line, say for example the one that's selected, to this line, right? There's 20 points across, and then there's also 20 points across from, say for example, this one to this one. Okay, so in other words, this has to be exact. Okay, you have to make sure that all of the lines are equal distance apart. So what I would do is I would just create one of these, say for example, and then I'll hit Control-C, Control-V to paste it, move it into position. So say for example, if I wanted to move it right here, right, use my mouse, or not my mouse, my keyboard to make sure that it's at the appropriate distance. So in this case, I'm going to move it up over here until it's 20, so that's 300. That's good because this one was another number here. What number was this here? This one was 320, right? So x, y axis, that's 320. So this one is going to be 300. That's 20 distance apart. Then I'll take this one, copy and paste, and move it up, copy and paste, move it up, so forth and so on. Okay, so that's how you're going to have to make this Cartesian coordinate. And then you'll just simply create some more labels, right? So I just took this, copied it and pasted it 15 times, copied it and pasted it 15 more times, and then just position it, right? Just move it into position so that the numbers are right underneath or to the left of each of the different Cartesian coordinate lines. So that's how you would approach creating this Cartesian coordinate. And here's another thing to consider in terms of a Visual Basic form. All right, so let me just go ahead and take, say for example, this label. I'm going to copy and paste it. I'm going to show you something. Let's say that I move this form to, or this label to the upper left-hand corner, right about here, say for example. Well, you'll notice in terms of its location, it says that it's at 8, 1. All right, let me go ahead and change this so that it's at 1, 1, just to show you what happens. So 1, 1. You'll notice that, first of all, the anchor point, or the point of reference, or the point of origin for this label is the upper left-hand corner. It's this handle right here. Currently, that handle is at the 1, 1 position. Right now, you can see obviously this thing it's larger than just 1, 1. In fact, its size is 20, 20. All right, so what's going to happen is this. Anytime that you are referring to the location of any of these labels for the houses, right, house 1, house 2, house 3, or the water tower, you have to remember that it's the upper left-hand corner that is the anchor or the reference or the origin for that particular label. That's one thing. Here's another thing to notice. Let me go ahead and select this label, and I want you to notice I'm going to hit the down arrow on my keyboard so you can see it's moving down. But notice what's happening over here to the location values. Do you see how they're increasing in value? So right now I'm at 30, 31, 32, so forth and so on. As this thing is moving down, I'm hitting the arrow on my down keyboard, or I'm sorry, I'm hitting the down arrow on my keyboard, I should say. And again, the thing I want you to notice is that for the y-axis, as you can see here, this is changing. So in other words, this right here is the 0, 0 point for the form, and going down is positive. Now I know that seems weird because typically, for those of us who took, was it pre-algebra or geometry? I can't remember what division of math that is, but on a Cartesian coordinate, the 0 axis is right here, and when you go up on the y-axis, it's positive numbers, and when you go left on the x-axis, it's positive numbers. But what I'm saying to you is that in Visual Basic forms, here is the origin right here on the upper left-hand corner. That seems weird, but that's something you're going to have to remember. The origin is here on the upper left-hand corner, and moving down yields positive axis or positive integers for the y-axis, as you can see here. Now watch this. I'm going to hit my right keyboard arrow, and as I'm hitting the right keyboard arrow, notice what's happening to the x-axis here. It is increasing. So in other words, to increase either the x-axis, which is what I'm doing right now, or to increase the y-axis, you have to understand that increasing the y-axis means moving it down, as you can see here, and increasing the x-axis is moving it to the right, as we would expect. Okay? Now that's going to be important. Here's why. After you have established, let me go ahead and delete this guy right here. After you have established your Cartesian coordinate, then I would go ahead and create these labels. And what I'm going to do is I'm going to take that label and I'm going to move it to the 0, 0 intersection of the Cartesian coordinate. As you can see that house 1 is in. So with house 1 in the 0, 0 position, I now know where the origin is or where to put my house if, say, for example, the user said, I want house 1 to be located at 0, 0. Well, first I'm going to move it to 0, 0, and notice this, the location for this particular Cartesian coordinate 0, 0 is actually 33, 13. So we have to remember 0, 0 for the form is right here. But from the user's perspective, you've created this Cartesian coordinate. 0, 0 is where house 1 currently is located. So in other words, what you're going to have to do is say, well, if a house is on 0, 0, what does that mean in terms of the points or the pixels? Well, in this case, it's going to be 33, 313. That's where this thing is actually located. Now that I know the origin, I know that if I were to increase this by 20, or if I were to decrease rather by 20, it would move up. So watch this. Okay, y-axis is 313. I already taught you that when you move down, it yields positive numbers. If I'm moving up, I'm actually decreasing the number, right, as opposed to increasing it if I'm moving down. So in other words, 313 minus 20 is going to move this thing up. Watch this. All right, so 313 minus 20, what is that supposed to be? That's going to be 303, 393, right? So let me type in 393, 293 rather, and then press enter, and notice what happened. Now the house moved up. Let me now subtract that by 20, and that's going to be 273. As soon as I press enter, watch what happens over here. So I'm pressing enter, and again, it moved up. So decreasing the number moves this thing up. Now you may be asking, hey, how did you know it was 20? Remember, I told you that the distance from this line to this line is 20. So I know that once I have found the origin for the house, all I have to do is just increase or decrease it by 20 to move it to the next intersection of these of the Cartesian coordinate. All right, so let's return this back to 313, press enter. So now that I know that the origin is at 3313, I need to remember that. So let's go to the code area. All right, so in the code area, here's what I'm going to do. I'm going to create two different variables. One is going to be called x origin, the other one's going to be called y origin. The x origin is 33 rather, and the y origin is 313. And you now know how I was able to determine that. Well, the first thing I did was I just simply took a label and then moved it to the position and said, hey, where is, if a house is to be located right here on the 0, 0 Cartesian coordinate location. Where is that thing located? It's located at 33, 13. This is the x-axis. This is the y-axis. So that's why I create two variables. And notice that these are modular in scope. So this is going to be 33 for the x-axis, 313 for the y-axis. Okay, obviously I'm going to need to know the numeric locations for house 1, x and y-axis, house 2, x and y-axis, house 3, x and y-axis. That's why I create h1x, h1y, h2x, h2y, h3x, h3y. Alright, I'm also going to need to know the location of the tower that yields the least amount of pipe between it and all of the different houses. So for example, if it ends up that the best location for the water tower, given this configuration for the houses, like if house 1's here, house 2 is here, house 3 here, and let me just say, well, based on this configuration, let's say that the water tower should be here. Well, I need to remember that location. So what I'm going to do is I'm going to create two variables, min tower x, min tower y, and that tells me if the tower is located on this x-axis and on this y-axis, that will yield the total minimum of pipe from house 1 to the water tower, house 2 to the water tower, house 3 to the water tower. Okay, so that's the idea behind this. Delta is just a typical Greek letter that's used for distances, right? And so the idea here is this is the distance from this grid line right here to this grid line right here, and then this is the distance from this grid line to this grid line, right? So the idea is I want to make sure that I know what the distance is based on my graphical user interface, and it ends up that that's 20, right? Because I designed it that way. Okay, so those are some of the initial values that I need. Now, some of the easier things to do, like say for example for the exit button, that's really easy. All I have to do is just me.close. I won't even cover that. Well, actually I did. Okay, how about this now? Let's say, for example, that the user selects a value for one of these combo boxes. All right, so let me scroll down to that so I can show what that looks like. Actually, before I'm not going to do that. Let me go to the Properties menu. Tack this down, and I'm going to show you here. Let's see here, items. Here we go. All right. So in order to establish what items are going to be displayed in the combo box, first you have to select it, then you're going to go to the items property, and then under collection you're going to click the button as you saw me do earlier. And then this is going to pop up. And as you can see here, it's pretty easy. It just tells you, enter the strings in the collection, one per line. Well, the first thing that I did over here is I pressed enter. And then that took me over here, and then I'm going to type 0, and then I'm going to type 1, and so forth and so on, all the way up to 15. So I want the ability for the user to select blank, because if the user is going to click clear, then I want these to be cleared, so one of the options has to be a blank. Then the next one is 0, 1, 2, 3, so forth and so on, all the way up to 15. So that's pretty easy. For each one of these different combo boxes, go to items, click this guy over here, this 3-button ellipsis button, and then go ahead and type blank, and then 0 through 15, then click OK. So that's how we are able to restrain the kinds of values that are actually going to be located, or that are actually going to be displayed every time the combo box is selected. All right, let's see here. I think that's it. I'm just going to try to look down here to show you the different properties here that you might need here. Let's see here. Drop-down style is drop-down list. That's the one that I selected. You can see how that you can play around with this to see what changes actually occur. And let's see if there's anything else I need to talk to you about. Collection, I just talked about that. I think that's it. Tab stop. Yep, that's it. Okay, so that's how you're able to get these values into the text boxes. Now let's go ahead and talk about the coding for the clear button. Now in this case, if the user clicks clear, then these labels are going to, their visibility property is going to be set to false, and we need to set the index of the item that's going to be set to 0. Here's what I mean by that. So for example, for this particular combo box, that combo box, you've just typed in all the different values. Now, This value right here is index 0. This is index 1, index 2, index 3, so forth and so on. So the index basically says, hey, do you want this first value? Okay, that's index 0. Do you want this second value? That's index 1. So indices typically start with a 0. So the reason why I'm explaining that to you is now you can see why. If the user clicks the clear button, then what I'm going to do is for the combo box dot selected index, select 0. You remember that the first value is the blank, right? So in other words, I want these things to be blank because I'm clicking clear. So what I'm saying is for combo box h1x, h1y, h2x, h2y, so forth and so on, the selected index is going to be 0 because I want that 0 index of the blank to be selected. So in other words, just to show you once again, I want this one to be selected, the top one right here. It's just blank, right? It's not 0. So in other words, if I did this, this would be a mistake. I'd have 0 from 15, that's good, but the 0 index in this case is 0. I don't want that. I want that 0 index to be blank. That's why I pressed enter. Okay. All right, so that's the first thing that we're going to do. Let's go ahead and set all the combo boxes to blank. Next, all those labels, LB1, LB, H1, H2, H3, so forth and so on. So these labels right here, and also the water tower, let's make those invisible by setting the visible property to false. And then what I'm going to do is, we have to be careful with these buttons right here. If I'm clearing all the houses, then I don't want the show tower button to be active. So what I'm going to do is I'm going to say show tower enabled, set that to false. And the idea is this. You can't show a tower unless you have house values. If I just click clear, there are no house values. Therefore, you should not allow the user to click show tower because that option doesn't exist until the user clicks all these combo boxes and then they click show houses, then they can click show tower. Okay, so that's the logic behind BTN clear. Let's talk a little bit now about the BTN show tower click. Well, first of all, let me go back to the handout and explain something. One of the equations that you're going to have to use is the distance equation, and that's what this is. So the distance equation basically says this. We use it to determine the distance between 2 points on a Cartesian coordinate. So let's say, for example, that you have house number 1 and the water tower over here, and you're wondering, what is the distance between these 2 points? Well, to determine the distance between those 2 points, here's what you would have to do. You'd have to use this equation that says x2 minus x1 quantity squared plus y2 minus 1 y1 quantity squared, and then take the square root of the whole thing, and that's going to give you the distance. So the idea is this. Let's say that I take h1, take its value, so it looks like the x-axis is 1, so let's say that I put the number 1 over here, and then for x1, let's say that's going to be represented by the water tower. Okay, so the water tower is on number 6, so number 6 would go over here. Okay, so this would be 1 minus 6, right? So 1 minus 6, that's negative 5. Squaring any negative number turns into a positive. So far this would be 25. All right, take y2 minus y1. So what's the y-axis position for house 1? That's 1. What's the y-axis position for the water tower? That's 7. All right, so 1 minus 7 is 6. 6 squared is 36. So 25 plus 36, we're going to add those two together. We're going to take the square root of that. And that is going to be the distance. It'll be the distance between house 1 and the water tower. You now have to use this equation for determining the distance between house 2 and the water tower, and also house 3 and the water tower. Once you have those 3 distances, you now have the total distance of all the houses to the water tower. And that's exactly what you're trying to do. Determine the total distance based on this current water tower position. Okay, so now that you have that, here's what I'm going to do. In the show, I shouldn't do the show tower. Let's do the show houses first. So let's go over here to show houses. Here we go. All right, well, the first thing I got to do is I got to obtain those values. Well, what I'm going to do is I really should have converted here. So let's say convert dot to I think these guys are, what are they here? Hold on for a second. They're integers. Okay, so convert to integer, parentheses, close parentheses right here. Let's say convert dot to int 32, sorry, to int 32, not to unsigned integers, to int 32. There we go. All right, so I take the value that's in the combo box, convert it to an integer, and then assign it to h1x. I'm going to do the same thing for all of these. So let me just go ahead and copy this and put that here. Copy this, put this here, so forth and so on. In fact, let me just do it this way. Let's close this, and then I'll put the closing parentheses at the end of each one of these. All right, so whatever the value is in the combo box, assign that. We're going to convert that to a number and put that in h1xy, h2xy, h3xy. Once I have that, let's position each of the different labels based on the user entry. So I have the values, but here's the thing. Let's say, for example, that the user enters in 0, 0. Well, you know from the form's perspective, based on what I said earlier, the 0, 0 point for the form is right here. Well, that's not what the user meant. If the user enters 0, 0, what they mean is put it here. Put it right here on the Cartesian coordinate that you've drawn on your form. So all of that has to be taken into consideration. So in this case, if I'm going to position each of the labels based on the user entry, here's how I have to do that. So I'm going to use the left and the top property for the labels. The left property just simply means from the left, right? So say, for example, if I take this, let's take this label over here. All right, so from the left, which is this side over here, move inward a certain amount, or from the top, move down a certain amount. That's all that means. So in this case, from the left perspective, the first thing I'm going to do is take the x-axis origin. I'm going to then add that to the multiplication of house 1x times delta. So first of all, by doing this, by saying, first of all, from the left, let's consider the x-axis origin. All right, so from the left, where is the x-axis originating from? It's going to originate right here. This is the 0, 0 location. So that is something that we determined up here. And we said that the x-axis origin is 33, the y-axis is 313. Okay, so what this means is move 33 from the left. So if I were to take this over here, and let me open up the properties here and tack that down. Okay, so let's see here. Keep an eye on the position here. Let me select this label and location. Here we go. All right, let me select this over here. Notice it's 33, right? Okay, so let me take this back to the 0, 0 location. And right there. Okay, so currently, and actually, no, let me just move it down here a little bit. Here we go. All right, so currently, let's say that my label is right here on my form. Well, the first part of the equation says move the label from the left this amount so far, x origin, okay? Well, x origin, as we saw earlier, was 33. Right, there it is. X origin is 33. That's what we established. All right, so now let me select this and move it 33. So this isn't the way it's going to work out in runtime. I'm just showing you or trying to explain it to you step by step. I got to move this thing by hitting my right arrow. I got to move this thing to 33. Okay, there we go. It's 33. So we have moved it now from the x-axis to 33 position. All right, so now let's go back over here to the code. And what else do I have to do? Plus, okay, so let's say that the user typed in 0, 0, right? For the x-axis, they want this house to be at the 0, 0 location for the x and for the y-axis. Well, 0 times anything is 0, so that would stay in place. Maybe I should change this. How about if the user says, I want this house to be on the 1, 1 position? Okay, so if this is 1, then 1 times delta, and remember delta we said was 20, and the reason why we said it's 20 is because that's the distance from this line to the next line to the next line. They're all spaced out by 20. They have a spacing of 20 in between them. All right, well, the reason why I need that is because now I can say take whatever the value is that the user wanted, multiply that times delta. So if they wanted it on the 1 position, it'd be 1 times 20. If they wanted it in the 2 position, that'd be 2 times 20, 3 times 20, 4 times 20, so forth and so on. This tells me how far to move from the left. All right, well, in this case, if the user says, I want this thing on 1, 1, well, 1 times 20 would be 20. So let's add an additional 20 to this. All right, so I'm going to go to the form. Here it is, and I'm going to add 20. So again, you're going to keep an eye on the location here for the x-axis. So let me go over here and add 20. So that's going to be the 53 points. So we keep on going because 33 plus 20 is 53. So there it is so far. That's the label location. All right, now let's go ahead and execute the next statement, which is LBL1, LBLH1, I should say, from the top perspective. First of all, from the top, increase it by 313, because remember, Y origin was 313. All right, so that's the first thing we're going to do. Take this and increase it by 313. Okay, so, oops, sorry, let me go back over here to the form area. All right, so currently it's at what? It's at 325, so I'm just going to go ahead and type in 313. Okay, so that is the y-axis, 0 axis, right? It's on the bottom. It's as far down as it's supposed to go. Now, if I want this thing to move up, remember that the value needs to decrease. Let me select this and remind you here. I'm going to start hitting my up arrow. Do you see how this value is decreasing? 302, 290 something, 280 something, so forth and so on. Moving it up means decreasing the value, because remember I said that this is the 0, 0 point. Moving it down, okay, I'm going to move it down now. Moving it down means increasing the number, so you have to remember that. All right, so currently this thing is at 313. Here it is. Now that that thing is at 313, that's why I say minus, because minus means moving this thing up. If I said plus, that would mean moving it down. And remember, I was just using the arrows to show you that moving it up means that the values are decreasing, so therefore I have to subtract. So from this y origin, I need to subtract it. Well, how much do I need to subtract it by? Well, in this case, notice that the user says I wanted this thing to be located at the 1, 1 position. Well, 1 times 20 is 20, so let's subtract it by 20. All right, so now I'm going to go over here, and I'm going to take that house, and I'm going to subtract it by 20. Well, notice it's at 313 right now. As I subtract it, I'm going to take it all the way to 293. So 313 minus 20, that's 293, and there it is. Okay, so now that I have this position, I now have a way, mathematically, as you can see here, using the left property and also the top property, I can use that to set my location of the house. I could do the same thing for house number 2 and also the same thing for house number 3. So the idea is this is going to position every single label based on the user entry, which that's this right here, and also based on my former evaluation of the x-axis and also of the delta, which is basically the distance between the different lines. Okay, so now that you have the position of each label based on the user entry, let's talk about the actual houses. So you see over here it says reveal the house marker labels. So here's the idea. What I'm going to do is I'm going to take all these houses, right? If I click show houses, I am ready to go ahead and show these actual labels, right? Because the user has already entered values into the various combo boxes. All right, so now what I'm going to do is I'm going to set the visible property of each of the different houses to true. So that's going to reveal the houses. All right, the next thing to do is once the houses are all displayed, now I can go ahead and enable the water tower button, because the houses, this button has been clicked, so let's take that button and enable it. How we're going to do that, I'm just going to set the enabled property to true. Okay, so that's how we're going to be able to show all of the different houses. Now for the last step, let's talk about the code for show tower. All right, for show tower, this is going to be a little bit more involved. Not a whole lot of code, as you can see here. It starts right here and it ends right here. But it's the concept that is going to be a little bit more challenging, so I want to make sure that I explain it to you step by step. All right, so in this case, notice what happens. First of all, in terms of my declarations, I'm going to create two variables that indicate the tower's x and y axis coordinate. So in other words, what's happening is here. Let's take this water tower, and what I'm going to do is I'm going to move the water tower from this location to this location to this location, right? My intention is to move it to the different intersections, and as I'm moving it to the different intersections, I'm going to evaluate the distance from the water tower to the different houses. Okay, so I'm moving it step by step, and then I'm constantly re-evaluating what is the amount or the total distance from each of the different houses to the water tower as I'm moving it step by step. Okay, so that's what Tx and Ty represent. It's the current location of the tower. I'm going to need to make sure that I keep track of the total distance, and then I'm also going to need to evaluate the minimum distance. Now, I set the minimum distance to a really large value at first, knowing that there's no way that the minimum value is initially, the minimum value is not going to be 1,000. Whenever I'm able to find out where that water tower location is, this plus this, right, that distance has to be something less than 1,000. So I deliberately place a large number here, knowing that when I reevaluate my minimum distance, it's going to be a value that's going to be much, much less. All right, so we'll get to this so it'll make more sense when I'm actually running the program. All right, so now we're over here where it says calculate the centroid of the triangle formed by the three houses. Okay, so the centroid basically is the middle position of the house, of the water tower rather, based on the triangle that is formed by the three houses. So in other words, if I made a straight line from house 1 to house 2, from house 2 to house 3, and then from house 3 to house 1, you would see that that basically forms a triangle. And so what's going to happen is the water tower is going to be in the middle of that water tower. That's called the centroid. All right, so the centroid then is going to be something in the middle of the triangle that I just demonstrated. So what I'm going to do is I'm going to take two for statements. I'll take this for statement, and I'll also take this for statement. This is a nested for statement inside of the outer for statement. All right, so for this outer for statement, here's what's going to happen. What I'm going to do is I'm going to take Tx, and its value is going to span from 0 to 15. So in other words, what I'm saying is, well, let me go back over here and just make sure, yeah, that's for the x-axis, right? So for Tx, here's what's going to happen. We're going to start this off here at the 0 location. Then I'm going to move it to 0, 1. And then I'm going to move it to 0, 2, or to 2, 0, I should say. And then 3, 0, and then 4, 0, and 5, 0, so forth and so on. I'm going to move it all the way across until I get to x-axis 0, y-axis 15. All right, so now that I have that, once I've gone through this loop 15 times, notice that I have an inner loop, right, which is basically going through the y-axis. So actually, here's what's going to happen. Tx is equal to 0, so that means that this is going to be placed over here at 0, 0. All right, then I have my inner loop, which is moving the y-axis from 0 to 15. So in other words, we're going to, actually it looks like it's going to do this. It's going to go y-axis equal to 0, then 1, then 2, then 3, and then when it moves all the way to the top, then we move it over to the next row and consider all these locations. Then I move it to the next row, consider all these locations, so forth and so on. So I'm basically scanning the entire grid. So that's the idea between the two nested for loops. All right. As I am moving the tower from each of the different locations on the x and also the y-axis, I need to determine the total distance. Well, how are you going to determine the total distance? Well, that's where you're going to have to use the distance equation, which is this guy over here. So what I did was I created a function called distance. And so if I go down here a little bit, here it is. Here's the distance function. All right, so the distance function is going to work like this. What you're going to do is you're going to send it two house parameters. So I say by value, send me hx parameter, and then you're going to send me the h par parameter. Those are both integers. You're also going to send me the tower. So you're going to send me the tower x-axis and also the tower y-axis parameter. So this function receives 4 different parameters. Based on those 4 parameters, now I can use the distance equation. Well, for the distance equation, it's going to be h2 minus x2 minus x1 quantity squared. So I use the power function for that. So math.pow, so what I'm going to do is I'm going to say take these two and subtract them, because that's what you have to do here, right? You take x2 minus x1, subtract them. So here's the subtraction. Now this 2 right here represents the power, which is this guy right here. So in other words, take the 2, subtract them, and then square them. So that's this entire section right here. All right, now that was for the x-axis. Let's do the same thing now for the y-axis, which is this part right here. So you're going to take y2 minus y1 quantity squared. So that's what we're doing, y2 minus y1 quantity squared. Once you've done all of that, take the whole thing and then find out what the square root of that whole thing is. So in other words, take this, And what I'm going to do is I'm going to put that inside of a math.square-root function to give you the square root of the whole thing. Okay, so that is what the distance function does. And notice what this thing is going to do. It's going to return a double. That's what this as double at the end means. Distance, you send it 4 different parameters, and then it's going to return a double. So now if I go back over here to the tower, let's see here. Here we go. So if I go back over here to the tower, notice that I'm asking for the total distance, which is the distance from house 1 to the tower, plus the distance from house 2 to the tower, plus the distance from house 3 to the tower. All those 3 distances, if I add them together, that's going to give me the total distance. All right, so that's how I'm able to calculate the total distance every time I move the tower to a different location on the grid. I have to recalculate a new distance. Now, once I have that total distance, I can ask the question, hey, is that new total distance that I've just obtained, is that less than my current minimum distance? Because if it is, then that's my new minimum distance. Well, remember I initially set minimum distance equal to 1,000? Well, now that it's 1,000, I can say, hey, let's take that total distance. Let's say that it's 15 or 16, whatever. Well, that certainly is going to be less than 1,000. So my new my new minimum distance actually is going to be whatever the total distance was that I just calculated. Now, I also want to keep track of the x location, the x-axis position and also the y-axis position. I want to keep track of those two because what I'm saying is this. Currently, where this tower is and where this tower is, that one is the one that yields currently the least amount of distance. So I'm going to put that into 2 variables that I created up here called min tower x, min tower y. Okay. Actually, I didn't create those variables here. Those were modular scope variables. Here they are, min tower x, min tower y. All right, so now this is the way that I always make sure to keep track of the least distance and the position of the towers that achieve that least distance. So what's going to happen is then that's going to be ty equals to 0. Then ty is going to equal to 1. And then ty is going to equal to 2. ty is going to equal to 3, so forth and so on. We're going to keep on going this all the way until ty is equal to 15. And every time we're looping through this, we're calculating the total distance. We're asking the question, is that total distance less than my previous minimum distance? If it is, then I have a new minimum distance and I have a new location for the towers that yield that minimum distance. Once I've done this 15 times, now tx is going to go from 0 to 1, and then ty goes from 0 to 15 all over again. So this is going to be tx 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then tx is going to be 1. ty is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then tx is going to be 2, and then so forth and so on, right? So this is the inner loop, this is the outer loop. When this thing is finished, I will now have my new min tower x, min tower y location. In other words, this is going to be the location of the tower that yields the minimum distance, and that's exactly what I'm looking for. Well, once I have that, so I can just say, hey, let's now make that label, the water tower label, which is this guy right here. Right, let's make this one visible. So visible attribute is set to true. Now I can position that label, and the way that I'm going to position that label is I'm going to say, first of all, take from the top perspective, I consider the y-origin. From the left perspective, I consider the x-axis origin. And so, similar to the way that I position the houses, what this formula does is it basically positions the water tower based on this location right here being the 0, 0 point. Well, you know that this is the 33, 3, 13 point if I'm considering from the form's perspective. So this formula allows me to move the water tower to the correct position. All right, and I think that's it. So let me just start from the top here and make sure that I've covered everything. So we talked about clear, we talked about show tower, we've talked about show the houses, we've talked about the distance function. I think that's it. So let's just run the program and let's stop it. Let's say, for example, at when I click show houses. So let's stop it right here at this assignment so that we can follow the flow of the code and understand how that's going to work. All right, so let me run the program. And let me enter some values. So let's say that house 1, I want that to appear at the 0, 0 location. house 2 at the 0, 15 location, house 3 at the 15, 15 location, which is right here. All right, so now let's go ahead and click Show Houses and watch what's going to happen. Now, first of all, you'll remember that I put a break over here, so it's going to stop the code over here. And in a second, we're going to be able to take a look at the content. Okay, so what I'm going to do is I'm going to take this house, which is currently equal to 0. Let's convert that to an integer and put that into h1x. All right, so now if I click Step Over, you'll see that h1x is equal to 0. h1y is going to be equal to 0. Okay. Now the text in here is 0, so h2x is going to be 0. The text in the combo box h2y is 15, so 15 is about to be placed over here. So if I step over, sure enough, h2y is 15. And so I'll just go through h3 really fast here. So the idea is let's get the user values from the combo box and place it into the variables. Now that I've done that, let's position these. So that's what these 6 statements are going to do. So I'll just go ahead and step through each one of these, and then I can highlight them to give you the different values here. All right, so in this case, notice that the label 1 dot top is 13. For the left, it's going to be 313. This is the number of points relative to the form position. All right, let's make those 3 houses visible. So we're going to make them visible. So we'll do that. And then finally, let's make the Show Tower button enabled. By the way, let me go ahead and stop when it gets to the Show Tower. Let's stop this right here so we can follow that code as well. All right, so let me go ahead and continue. So now you can see that the houses have been positioned, right? House 1 is at 0, 0, good enough. House 2 is 0, 15, there it is. House 3 is at 15, 15, there it is. Now I'm going to click the Show Tower. The Show Tower basically is going to make sure that the tower is going to be somewhere in the middle here. That's what it's supposed to do. So let's see what happens. I click Show Tower, and now we're back over here in the code area. All right, so what I'm going to do is I'm going to say, let's make it so that we start off with the tower location at 0. So that's what this first for loop does. The next for loop says for the y-axis, let's also start it at 0. So tx and ty, as you can see here, are 0, 0. The total distance is going to use the distance equation. So let me just show you that once. So I'm going to step into. So what it's going to do is it's going to take that first house, which was at 0, 0. It's also going to take the tower, which is also at 0, 0. Okay, so now you know that everything is zeros. So it's going to return the distance between those, which we know is going to be 0. Right, so let me just go ahead and step through that. Okay, return the function. So what we did was we just sent this to the function. Now let's go ahead and send this to the function distance. Right, so and then we're going to do the same thing over here. We're going to send this distance to the function as well, or the variables, I should say, to the distance function. All right, let me just go ahead and step over this. Inevitably, we see that the total distance for the houses placed as we entered them initially is 36.2132, blah, 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 blah. Okay, so that's the total distance so far. Well, then the question is this. Well, here's my new total distance. Is that less than my previous minimum distance, which was 1,000? Do you understand now why I set it to such a large number, knowing that there's no way that this thing is going to be able to go on and allow the minimum distance to be 1,000? Once I've established the distance for that first tower location, it has to have a new value, which is going to be less than the minimum distance. So this is a true statement. 36 is less than 1,000, so therefore we're going to go into the if statement. My new total distance will be assigned into min distance. So min distance now becomes 36.213 rather. Now the new x-axis, which is 0, and the new y-axis, that's going to be placed into the min tower x, min tower y variables, because currently that is the location of the tower so far that yields the minimum distance. All right, so now that I've done that, go to the next. Let's go now to ty is equal to 1. Okay, so we're going to go from 0, 1, 2, 3. So now we're moving ty to the 1 location and asking the question, what is the total distance? Currently, the total distance is 36.21 from the previous location of the tower. But if I now evaluate this, what is it? It's going to be 35. Hey, that's less, right? See, my previous distance was this, min distance. And my new total distance for the new location of the tower is this. Is total distance less than min distance? In this case, it is. So it goes into the if statement, and it's going to calculate, or it's going to assign the new total distance, tx location, and ty location. and we do the same thing all over again. So we're going to go through this 15 times as the house is moving up the Cartesian coordinate, and then finally when this is finished 15 times, then we go to the outer loop to do all of the different rows. So 15 row 1, 15 row 2, 15 row 3, 15 row 4, so forth and so on. Okay, so we're going to keep on doing that, and then finally when we're finished, let me just go ahead and click continue. The water tower is going to be placed on the appropriate location based on these houses. Now if I wanted to move the house positions around, so for example, let's say that I wanted this house to really be located at 8, 0, say for example. Let me go ahead and click show houses. Let me take off this breakpoint and go ahead and just click continue. And then I'll click show tower. And then again, I'm going to take off this breakpoint and then click continue. Alright, so now based on these 3 house locations, the water tower should be placed here to yield the minimum distance. Alright, well first of all, I wanted to make sure that this was in fact the case, that this program actually works correctly. So what I did was I opened up, or I created an Excel spreadsheet. So let me just show you that really quickly. Alright, so I created this water tower Excel spreadsheet just to make sure that my values were correct. So in this case, I mean, this is not a class on Microsoft Excel, but just trust me. The idea is the same. You're going to have houses in 3 different locations, and then what I'll do is I'll put those houses over here, and then it's going to give me the minimum distance, and it's going to highlight which one of them is the smallest one. Alright, so let's go back over here to my H1, H2, H3 location. So if the house 1 is located at 8, 0, okay, so this is going to be 8, and that's 0. And then house 2 is at 0, 15, okay, I already have that. And house 3 is at 15, 15, okay, I already have that as well. So you'll notice over here, it says that the tower should be located at x-axis 8 and y-axis 11. Is that what our program did? X-axis 8, y-axis 11. Perfect, that's exactly what I did. Let's try some different values just to make sure that my program works. Alright, so let's move house 3 down a little bit. So let's say, for example, that I want to move this down to, oh, I don't know, 12, say for example. So let me show the houses, let me show the tower. So now the water tower is supposed to be in this location. Let's see if that's true. So house 3 is now at 1512. So house 3 is at 1512. Well, it's saying now that the water tower should be at location x-axis 9, y-axis 9. Is that in fact where it moved it to? So x-axis 9, y-axis 9. Yep, that's where it moved it to. In this case, it's saying that the distance from house 1 to the water tower, house 2 to the water tower, house 3 to the water tower, it's saying that that distance is supposed to be 26.58 according to my Excel calculation. Let's see if that's true. So let me just go ahead and stop the program. And the reason why I'm showing you this is anytime that you're creating a program, you're probably going to want to evaluate to see if your program works, and sometimes you use other tools. And in this case, you can see that I used Microsoft Excel to make sure that my program was in fact calculating everything correctly. All right, so let's see here. What am I going to do? I'm going to put the 8, 0, 0, 15, 15, 12. So 8, 0, 0, 15, and 15, 12. 15, 12. Let me show the houses. Let me show the tower. And I put a breakpoint over here so that it would allow me to scroll back up and find out, hey, what is that minimum distance? Well, the minimum distance, as you can see here, is 26.58. Let me switch over to my Excel spreadsheet here. 26.58, perfect, that's exactly what it's supposed to be. So it looks like the program's working fine. And let me just go ahead and click continue here. And as you can see, everything works. Let's go ahead and clear, that works. Let's go ahead and click exit. And as you can see, that works as well. All right, so this, if you're able to understand this program, that is a significant achievement because this is something that I learned while obtaining my bachelor's degree in Fortran programming way back then. And we didn't have graphical user interfaces like this. It just showed us numbers. But I thought it'd be interesting to convert that old Fortran program into a graphical user interface that allows the user to enter initial values. Based on those initial values, make a calculation of where the best location is for the tower by scanning the grid, moving it around until it finds the least distance. Once it found that least distance, it's going to move the water to that location. and now you have an overall graphical view of what this layout is supposed to be. All right, so this is Professor Robert Solis. I hope this has been helpful. Have a good day. See you next time.